everyone. My name is Pierre Lapadrie, and I'm really excited to be here to present our work on browser fingerprinting. Today, the web is really beautiful. I mean, you can go on the web with any device that you like, any operating systems, any browser, any applications. And to make it all work today, you need HTML and JavaScript. So when you connect on a server, you say, all right, this is the type of my device, so this is my screen resolution. And then the server knows what version of the website to get back to you so that, in the end, you get a really comfortable experience browsing the web. The problem is with all this device-specific information that one can collect, we have what we call, in contrary to the beautiful part of the internet, what we call the beast. It's all the hidden trackers that are on the internet and that will collect as much information as possible on your device. And they use that to build a unique identifier called a browser fingerprint. So here is an example of a browser fingerprint. So on the left of the table, we've got the list of attributes that we collect. So we collect that through HTTP headers, JavaScript, and plugins if they are available. And you can see, that you can collect information on several layers of the system, on the browser, on the operating system, and even on the hardware itself. And so this list of attributes that we can see here are exactly the attributes that the great folks at the EFF collected 6 years ago when they did their panopticlick study. But in the past 6 years, a lot has changed, and the browser landscape has evolved. First, now a lot more and more people are browsing the internet with their mobile devices, and the time spent on applications and on smartphones is becoming greater than on desktops. And so what is the impact of that on browser fingerprinting? Are mobile fingerprints different than on desktops? Other thing is that every year there are new features and new APIs that are added in the browser. And so notably here we have the Canvas API and the WebGL API, so we can draw shapes in the browser and render 3D scenes. And so what is the impact of this API on browser fingerprinting? Can we use them to collect information? And finally, also something that is currently going on, which is the disappearance of browser plugins. Today, nphappy plugin, so it's the old plugin architecture, is being deprecated. So I'm going to get back later on that during the presentation. And also, the number of sites using Flash is quickly dropping. 5 years ago, there were approximately 50% of websites that had there was 50% of the top million websites that had a Flash component in the web page, and now it's dropping and it's less than 40%. So what's the impact of this disappearance of browser plugin on fingerprinting? And so to answer all these questions, we decided, all right, we are going to take this list of attributes. We're going to add more, so new attributes to Flash, to the WebGL API. So we use both new attributes that we discovered and also attributes that were discovered by other researchers. And we launched in November 2014 ammunic.org. So if you have your computer right now, you can go on it. And what the website does is that it collects your browser fingerprint and compares it to all the other fingerprints that were collected before. And so here is one of the main results of our study, which is the entropy for all the attributes that we collect. So on the x-axis, we have the different attributes. And on the y-axis, we have the entropy for all the attributes for different categories of fingerprints. So in green, it's all the fingerprints of our data sets. In blue, all the desktop fingerprints. And in red, all the mobile fingerprints, that is our smartphone or tablets. And so far, we collected more than 150,000 different fingerprints. And one interesting result that we got really quickly is that 90% of fingerprints that we collected were unique. That means tracking is possible. So basically, with that number, we confirm what the panopticlick study found out 6 years ago, is that by collecting enough information, you can identify easily users on the internet. And so now I'm going to get into detail. I'm going to detail several attributes. The first here is to show you that not everything that we collect is meaningful. So for example, here we have got the presence of cookies or not, or the value for the do not track header. And what we collect is basically a Boolean attribute, yes or no. And so with that, you don't learn a lot of information about a device. And so here we see that the entropy is very low. So if you want to identify a device with other fingerprints, you have to turn to other attributes. Now, if we take a look at the plugins and font, we can see on the bar charts on the left that there is a pretty big gap between desktops and mobile fingerprints. And the reason for this is pretty simple, because on mobile you don't have any plugins. HTML today is supposed to be complete enough so that you don't need to rely on any plugins to offer some features to your client. And also, since we use the Flash plugin to collect the list of fonts, since there are no plugin on mobile devices, we don't have access to that list of fonts. So that's why the entropy for mobile fingerprint is close to 0. For desktop fingerprints, in our dataset, it's the top 3 of the highest revealing attributes. And we basically confirm what was found out by Panopticlick 6 years ago. They concluded exactly the same thing. And also, we were incredibly surprised by the wealth that we discovered. We detected more than 2,400 different plugins and more than 220,000 different fonts. So if we did not collect that, we would have never guessed there would be such a big diversity of fonts and plugins on the internet. Now, if you take a look at the user agent, we can see that overall it's pretty high for both desktop and mobile. But what surprised us the most here that the entropy for mobile devices is the single highest value of our whole study. And so we wanted to understand why. Why is that? What makes user agent on mobile devices so different than on desktops? And so here is an example of a user agent taken from the Facebook application. And here are some information that you cannot find on desktop that you can find on mobile devices. So you can see here that we can find the model of the phone here with the iPhone string that we can find in the user agent. We can also find out the exact version of the firmware that is used, and it's up to the minor updates. So basically, all the iOS and Android user base is divided into several categories with each their own firmware version. And then we were also really surprised to find out that apps are not restricted in any way to modify the user agent the way they want. And so here, the Facebook application has access to your phone operator, and it directly includes it inside the user agent. So normally something that the browser doesn't have access to, the app does have access to that information and includes it in the user agent. And so, yeah, for all these reasons, the entropy for the user or for mobile devices is high and higher than on desktop. And also, yeah, one smartphone out of 4 in our dataset was instantaneously recognizable with just the user agent. So for us, it was pretty surprising. Then for the last focus I want to do on the attribute that we collect is about canvas fingerprinting. So canvas fingerprinting is a newcomer in the family of brother fingerprinting. It has been discovered recently, and we are the first on Ionic to do a large-scale analysis on the diversity in the client side. And what canvas fingerprinting consists in, we use Canvas API to draw shapes and render forms in the browser. It's basically a big drawing board where you can draw anything that you want. And what's interesting about canvas fingerprinting is that the result depends on both hardware and software. Depending on your operating system, on your graphic card, on the phone that are installed, the result will change. And so now I'm going to explain a little bit deeper what it's all about. So how does it work? Well, it's really simple. We send a JavaScript file with all the instructions for the browser to execute. Then, depending on its configuration, the computer will generate a picture and it sends it back to the server. So what's interesting here is that we can recreate the image and see exactly what the rendering for our canvas test is for each device. And so our test, here we create the canvas element, we specify the dimensions, and then we say, all right, browser, can you draw me an orange rectangle at this specific location? We say, also, can you render me this string with all the letters of the alphabet and a specific Unicode character at the end? And what's specific about this is that we ask for a font that does not exist. And so what does the browser do? Well, it uses what's called a fallback font. It's a font that is used in case a glyph is missing or is not supported, or in case the font that is being asked is not present on the operating system. And so this fallback font is interesting because depending on your device and your operating system, it will be different. And finally, the last thing that we ask is we ask the browser to draw the exact censoring a little bit bigger with a different color and with a font that is much more common in today's operating system, which is the Arial font. And so here is the result of the Canvas test for my own laptop. So if you go on myunique.org right now, you can see how it looks on your own device. And our result is that canvas fingerprinting is the fourth highest revealing attribute in a fingerprint, which is pretty high. And what's important also is that canvas fingerprinting is really stable. You can run the test many, many times, and you will always get the same result. And I'm pointing that out because we tried using the WebGL API to draw 3D forms inside the browser, but we didn't find the right set of parameters to tweak so that the result that we would get would be stable enough for us to use. And what we found out is that there is a big diversity of renderings between devices. You can have a difference between pixels, a difference between with the font that is used. And what you can see here is that the last character is special and is different. And in fact, it's an emoji. So an emoji is not an emoticon, it's a representation of an emotion. And depending, and it's up to the font developer, to provide their own interpretation of that emotion. And so depending on the operating system, and even depending on the manufacturer of your device, the font which contains the emoji can differ. And so by just collecting this single character, you can learn a lot of information about a user's device. So for all these reasons here, canvas fingerprinting is a pretty strong addition inside a fingerprinting script today. Now I want to talk about some future scenarios. So what would happen to browser fingerprinting if some evolution happened inside a browser? So here's a scenario, which is the end of browser plugins is something that is currently going on. So several years ago, Google said, all right, the old NPAPI plugin architecture is the leading cause of crashes, bugs, and security incidents, so we have to remove it. And so from the version 42 of Chrome, they disabled the support of NPAPI plugin. And from the version 45, they completely removed the support of this plugin. And what we can see on the graph is that as soon as the support of this plugin is disabled, the entropy is quickly dropping, and it's coming down to almost zero. And so where we saw earlier that plugins and fonts were really useful to identify desktops, in the future plugins that are used in browser fingerprinting will become much more limited. Also, in a scenario which is much more unlikely, which is what would life be without JavaScript, or another term, what would happen if everybody tomorrow decided to use something like NoScript. And with JavaScript, we have 90% of fingerprints that are unique, and if we remove JavaScript, so that means that we don't collect anything from JavaScript, but we only have HTTP headers. The number of unique fingerprints drops to less than 30%. And if we combine that with what we call generic user agents, we drop to less than 10%. So generic user agents for us is user agents that are much less precise. So when we saw earlier that we could have the phone model and the firmware version of a device, for us, generic user agent will be something like, instead of having Nexus 5X with Android 6.0.1, we would have maybe a mobile on Android 6, but not much information, so that in the end, much more people would share the same user agent. And now, at the conclusion to the presentation, browser fingerprinting today is still as easy as it was 6 years ago. With a simple script, you can collect many device-specific information without any really big problem. Canvas fingerprinting, which is a newcomer here, is really stable and has a high entropy on both desktops and mobile devices. Mobile fingerprinting is also possible, but for different reasons than on desktops. On mobile, it's mostly the user agents and Canvas fingerprinting, which helps us identify devices. But on desktops, it's still plugins and phones, even if in the future it's going to change. And finally, we show that some simple browser modification could drastically improve privacy without really impacting the way the web currently works. So thank you for your attention, and if you have any questions, don't hesitate to ask.
Hi, this is Pratik here from NUS. I think it's an interesting study, but you started the talk by saying the reason why people are fingerprinting is to do with customization of what content gets served, right?
Yeah.
So I'm wondering if you've had thoughts about a follow-up study saying that how many of these features really are being used by websites to deliver different content, right? So we can clearly see that there are lots of attributes here to track you, but if none of them are really useful for targeting content, then maybe we can just take them out. And also this also has to do with things like the JavaScript-based fingerprinting. I mean, browsers are updating all the time, and that's very clear that we are going to see a lot of fingerprints given this frequency of updates, right? So any thoughts on where to go next from this kind of a study?
Well, the thing is today, with all the attributes that we collect, a study on how they are used really truly by website would be really interesting. But the thing is, for example, if you take the user agent, if you download a software, a website can parse the user agent to give the correct version of the software, depending on your operating system and on your browser. Or, for example, the screen resolution, you may don't see it, but maybe all these responsive websites use that to adapt live all this content. So it should be really interesting to do a study to how much of this attribute that we collect are really used, and how much we could do to maybe remove them or maybe limit them to be much less precise so that it has a less bigger impact on identification.
Okay, let's rotate here.
Thorsten Holz from Ruhr University Bochum. So I have two questions related to the mobile fingerprinting.
Yeah.
First, are you actually fingerprinting the mobile device, or are you rather fingerprinting the application? Because in your example, you had Facebook and probably Safari. It looks completely different.
We are fingerprinting. We are collecting information with the way the user is connecting to the website. So if he's using the browser, we are communicating with the browser to collect information. If the user is connecting through an application, we are using that too. But most of the time, for example, the Facebook application, it's people who open links to the Facebook application, and it's like a web view who opens that they use to visit our website. So we don't necessarily communicate with the app to get information on top of what a browser can access to. But yeah, we're basically limited to browsers in general. I don't know if that answers your question.
Yeah, to a certain extent. And the second thing is, so for Android, I can see that there's a huge difference. But for, let's say, two Apple iPhone 6, can you also differentiate between both, or do they look the same? The thing is, today, there is a lot of diversity. So if firmware versions are different, or if some people use applications that are less widespread, for example, you can go on the Apple Store and download maybe a browser that not a lot of people are using. So if you don't limit yourself to what's basically included inside the smartphone, the default things, you may really have a fingerprint that is different than the majority of people. Okay, so this implies basically for, let's say, iOS devices, you cannot really differentiate between them. You just know this is some iPhone, but you cannot pinpoint it. So you cannot really fingerprint one device, but just know the class of iPhones. we can fingerprint a certain part, but then exactly, you know, if we take we didn't have made any study, but if we take the exact same phone with the exact same hardware and the exact same application installed on it, we don't know yet if there could be differences or tests that can be run that could differentiate them. So we don't, because, you know, all the people that are connecting our website, we don't know the full extent of that configuration. So we, you know, a test with exactly identical device would be really interesting to do.